Hello guys, welcome again to this video. In this video what we are trying to do is to continue our journey on the odd and even functions, and would be doing the odd function case. So what it meant was, if there is a function f of x such that it is integrable in a comma b, then minus a to plus a, actually it is integrable in minus a to plus a, let's say fx dx is 0 if f of x is odd, right? And rather we also proved the case where it is 2 times 0 to a into fx dx if f of x is even, right? Okay, so let us prove the odd case. So as before, we break out the integral as follows, which is minus a to plus a fx dx equals to minus a to 0 f of x dx plus 0 to a f of x dx, right? Right. So let us try to evaluate this integral again. Let us call it j, and we shall see what this gets us, because fx is an odd function in this case. So j equals to minus a to 0 f of x dx. So we make the substitution y equals to minus x, because then dy would be equals to minus dx, and as for the limits, y lower would be minus of x lower, which is minus of minus a, or which is just a, and y upper would be minus of x upper, which is minus 0 or 0. Therefore so y lower is a, y upper is 0, f of x becomes f of minus y, and dx becomes minus dy, right? So basically we have minus a to 0 f of minus y dy. Now since indefinite integrals are independent of variable changes, we can write this as minus a to 0 f of minus x dx, right? And we remember that since this is an odd function, it means that this should be equal to minus a to 0 f of x, but there should be an extra minus here, because f of x is equals to minus of f of minus x in case of odd functions, and these two minuses together give you a to 0 f of x dx. But we remember that a minus changes the limits of the reverses the limits in an integration of definite type, so we can write this as minus 0 to a f of x dx. So this is our j. So as you can see here, minus a to plus a f of x dx was equal to j plus 0 to f x dx. So let us write that down. 0 to f x dx, so 0 to f x dx plus 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 to f x dx, so let us write that down. 0 fx dx, and j turned out to be minus 0 to a fx dx, and these two integrals are the same, and they cancel out, minus and plus. The answer is 0, which is the answer in case of a odd function. So we have basically covered both the odd and the even functions here, and it basically means that when we want to execute this odd and even functions on a separate note, we should be careful about how to solve them. So let us see an example regarding this. So this was the example that we had done previously, right? So minus 1 to plus 1, 2x by 1 plus x square. So first let us checking if 2x by 1 plus x square is odd or even. So to check that, we need to set f of x equals to 2x by 1 plus x square, and we are going to evaluate f of minus x, which is basically 2 of minus x by 1 plus minus x whole squared, which is minus 2x by 1 plus x square, but this is just equals to minus of fx. So f is an odd function. Right? Therefore, since the limits are minus 1 to plus 1, which are of the type minus a to plus a, therefore minus 1 to plus 1 f of x dx, which is basically minus 1 to plus 1 2x by 1 plus x square, is equal to 0. Right? Let us do another example. So this is another example, and we first need to know that cosine x is always a even function, because cosine of x is always equals to cosine of minus x. Then I equals to minus pi by 2 to plus pi by 2 cosine of x dx would be equal to 2 times 0 to pi by 2 cosine of x dx, and this would result, since cosine x is an antiderivative of sine x, that would mean that this is sine x from 0 to pi by 2, which is basically 2 times sine pi by 2 minus sine 0, which is 2 into 1, which is 2. So this is the value for the integral. Also remember that 0 to pi by 2 cos of x dx is always equal to 1. This is particularly helpful when you are trying to solve definite integral problems on trigonometry. It's very helpful back then, right? So this would be I think this would be all for this lecture, because we have solved we have solved the odd function case in this lecture, and we got a review of how to do the definite integrals and how to change limits, and then we did like 2 examples on odd and even cases, and that should make things clear about how these formulas work. In the next lecture we shall try to do some more problems on definite integration, and also do not forget to check out the link in the description for the Breatter Maths app.